So here is an example, basic example of simple harmonic motion. A particle obeying simple harmonic motion is oscillating between two fixed posts located 50 centimeters apart from each other. The particle begins at the origin and completes 12 oscillations in 2 minutes. First, the object over time. So you can go ahead and try this problem, and when you're ready, come back for the solution, which I've changed the format of. So as you can see, there's nothing here. So I'm actually going to handwrite the solution, which is something that I feel like should be necessary. So one thing that we've seen is that there's 12 oscillations in 2 minutes. So there'd be 12 cycles, or 12 oscillations, in 120 seconds. Therefore, one cycle or one oscillation occurs every 10 seconds, which means that the frequency is just 1 divided by this, so it's 1/10 of a hertz, which I'll write as just 0.1 hertz. So that's the frequency. We found that. So that's part 1. Part 2 tells us to find a general expression of the position of the object over time. So this is where we use our x equals a sine of omega t plus epsilon. Now, because f is 1 over t, this 10 is actually representing t. So omega is just 2 pi divided by 10, which is just pi over 5 per second. Now, one thing to be aware of is it starts at the origin, and the amplitude is 50 centimeters. Now, key thing, they are 50 centimeters apart from each other, so this distance here is 0.5 meters. And so when it's at its extremity point, relative to here, it would have traveled 0.25 meters. So this is our value of A. And if it starts at the origin, it would have started at its equilibrium position, which means that epsilon is 0. So filling everything in, we get x is 0.25 sine of pi over 5t. And that is an expression for the object's position over time.